So welcome to the videos for your specialist assignment for Term 1, Year 11. So our context is going to be that the Beenleigh Show has provided a substantial economic boost for the Logan region since its debut in 1872. The show is comprised of competitions for the best farm animals, best cakes, best sewing skills, carnival rides, and of course, carnival games. While some carnival games present as fair for both the player and the operator, the reality is that many games have been carefully adjusted over the years to increase the house edge for the operators. Some examples of this include changing the size of objects needed in the games, making them either slightly too big or too small, adjusting angles to increase the chance of missing the intended object, or changing the winning outcomes to be harder to obtain. Operators must be careful to keep the house edge between 15 to 25%, to ensure that other people see the game as achievable and are persuaded to pay to attempt the game. Okay, so the first thing that we're going to note down from that beginning is that we want 15 to 25% for the house edge. Now that makes sense because if you're at a carnival and you see a game and you watch it for a little bit and nobody wins it, you're not going to want to play it as well. So we want to make this something that's going to be achievable. Roughly about a fifth to a quarter of people that play are going to win a prize. Okay, now let's look at your task. So your task is to design your own unique carnival game, clearly outlining background information and rules. Your game must be interesting enough to motivate people to play it. So your first step is that you are going to create a carnival game. Now, we don't want to be too fancy with this. Keep it to things that are easy. You want counters, you want cards, you want dice, those sorts of things. Okay, so then you're going to decide on 5 specific winning outcomes. In your game, which can gain you an appropriate prize. Now, when you're picking your prizes for this, you need to think about this being a school assignment. So obviously, you're not going to be, winning things that you wouldn't talk about at school. You also need to be thinking about things that you would want to win at a carnival. So those little eBay things that you buy, like toys, pens, rubbers, inflatable things, all that fun stuff. Okay, so next part, appropriate prize commiserate with their relative probability. So calculate the relative probabilities across the 5 winning outcomes. You must demonstrate an understanding of permutations and combinations. So it must involve permutations or combinations. Calculations of the theoretical probabilities of your game design must meet the required house edge. So the probabilities of it happening must meet the house edge. Okay, and it gives you a little calculation below of how to calculate house edge, which is the expected return to the carnival folk multiplied by 100, divided by the amount spent by punters or players in this case. Either word would be appropriate. Okay, so we're going to simulate. After we've created our game, we're going to calculate the relative probabilities, and then we're going to use technology to simulate the outcomes of the game. Then we're going to compare our results, the theoretical results, which is the stuff that you calculate at the beginning of the assignment, to the experimental outcomes. Okay, and that is what we're going to be doing in the assignment. So if I start to, work out what I'm going to be doing with my game. Now, before I said that you could choose to do really anything that you want. So you just need to pick at least 2 things or one thing that's going to happen twice because you want it to be interesting. So you want to have a first event and then a second event at least. Otherwise, you're not really going to have enough to talk about. You could do more. You could be picking 4 things. You could be arranging things. All of that is fine. But you have to, pick something and stick with it. I think this is the hardest part of the assignment is the actual free choice at the beginning. So I'm going to go with a bag of counters because what math teacher doesn't love a bag of counters? Okay, so in my bag, I'm going to have 5 green, 4 blue, 3 red, and 2 yellow. And I'm going to call this game Double or Nothing. So, for you to win my game, you need to either get, so these are my 5 winning outcomes. You can get a green and a green, or you can get a blue and a blue, or you can get a red and a red, or a yellow and a yellow. What color am I missing there? Okay, I'm just going to go with 4 outcomes. In your assignment, you need 5, but this is just my example for you. So if I'm going to work out the number of ways that I can get a green and a green in my game, I'm really asking, okay, what's the chance that out of the 5 green, I'm going to pick 2, any combination of 2 greens. So out of 5 potential green markers, I want any combination and I want to pick 2 of the greens. Okay, so when I tap that into my calculator, I'm going to get the answer of 10. You may also choose to add in the other combination. So really I'm picking 5. Out of the 5 green, I'm picking 2, and then out of the 9 remaining, I'm picking none of them. Okay, the answer to this is just 1. Multiplying things by 1 doesn't change things, so you can have that in or not. But above this, I would have it written out very clearly in words. I would have out of the 5 green marbles, I am selecting any combination of the 2. Now, this is different if you were having permutations. I'm saying in this event, picking the first green marble and the second green marble is the same as picking the second green marble first and then the first green marble. Okay, these are not order specific. It doesn't actually matter. Okay, now we're going to look at how many ways I can I can obtain a blue and then a blue. So a blue and then a blue, which is going to give me out of the 4, I'm going to pick any combination of 2 blue marbles, which is going to give me the answer of 6. Same for red. Out of the red, any combination of the 2 red, I've got 3 to choose from, which is going to give me 3. And lucky last, out of the yellow, there's only 2 yellows. There's only one way I can achieve that. So out of the 2, I want to pick all 2. So now I've calculated my 4 winning outcomes. Remember, you need 5. The other thing that I need to do in this section is to determine how many ways I can win, how many different outcomes there are altogether. So down here, we're going to write total combos. Okay, and out of the total combos, there are 14 counters, and I want to select any combination of the 2 of them. Now in this, I'm saying that picking a green and then a blue is exactly the same as a blue and then a green. So this is an important assumption to state if it matters to you. Otherwise, you might be saying that they are not the same. Maybe you put numbers on the front of these things to make them identifiable, or maybe you care that you pick a blue first and then a green, that's the winner. Green and then a blue, no winner. When I put this into my calculator, I'm going to press 91. So just to refresh you on that, if you're in your calculator, Press Option, then go across until you see Probability. Click F3 to get the probability to select, and then there's all of your stuff for probability. Okay, so next thing I can do is I can pop over to Excel and I can start working out the theoretical probabilities. In your assignment, you might want to include the working of this, so I would just do yellow, yellow, or the probability of yellow and then a yellow is going to be equal to 1 out of 91 and get that as a decimal. In Excel, we're going to put in the fraction.